All right. Hey guys, you're gonna have to give me 1 minute. My computer was kind of being slow, and so I have to. The battery died. I have to re open up some of the files. Okay, cool. All right, so we are gonna go ahead and get started. The first thing I want to do before we actually get into the today's kind of new lesson is um, I want to go over the quiz. So where are we? Okay, here we are. So we had this quiz question that I had assigned for you guys. Um, and I said I wanted to make sure you guys did it by yesterday. So if you guys can get that out for me, um, just find it, take it out. I'll give you guys like a minute to do that. Um, Okay, so just post in the comments if you need more time to find the quiz, or if you guys have it. Okay, so I'm gonna go through this kind of quickly, um, since you guys have already had the time to do it. Um, so I did write this question. Originally there was a mistake in part D. I'm sorry about that. Um, but uh, that way, if I write the questions, there might be mistakes here and there, but that way it's kind of good practice where we can't necessarily Google them all the time. Um, so it gives you a little bit more of a feel for maybe uh, an actual AP question. So for A, they asked us to estimate the value of f prime of 5. Um, and I just want to kind of go over this. I'll be grading yours out of 9, but you can kind of go over right now and just ask me if you guys have any questions on these. So on A, just anytime we're doing derivative approximating, we just go in the table, what's on each side of 5, and then it's just y2 minus y1 over x2 minus x1. So you should have got a -10. And so that means that the number of flowers in Mr. Corey's garden is decreasing by 10 flowers per week. You could have also said is changing by -10 flowers per week. But you do need those units. You do need the flowers per week. And you do need at time equals 5 hours or weeks. So kind of the 10 flowers per week and the 5 you need. And you can either put decreasing by 10 or changing by -10. If you guys have any questions on any of these, just stop me. So one question was, what if we miss the at time 5 weeks? Honestly, if you don't put the at time, you'll probably get this wrong. Um, that's kind of a really important thing, is to always say when they ask you to interpret, you always need the what and the when. So the what is the 10 flowers per week, and the when is at time 5. Um, so that's something we really want to make sure we're practicing. Um, okay, we got 3 different Carloses asking questions. Carlos Vasquez, I think you asked, what if we just put at t equals 5? Um, if you put the flowers per week and then you just put at time 5, they might give it to you there because you had established that the time was in weeks. Um, but I would make sure that we're practicing this way, right? We don't want to take a chance. I would kind of probably put it like a 50-50 that they would give you the point there. And then Cuisine, I don't really understand your question. Cuisine, you want to either hop on the mic or just retype it, because I don't really understand what you're asking. Oh, okay, it was the same question. So you had just at time 5 without the weeks. All right, then B asked us, using the data, evaluate f prime of t. And just a quick note with integrals and tables, if we're taking the integral for a table, if you see the word approximate with an integral, you're going to either do some kind of a Riemann sum or trapezoid, right? But trapezoid's kind of like a kind of Riemann sum. If you don't see, and usually with this, they'll tell you, approximate it using a left-hand sum or approximate using a right-hand sum, right? They're going to tell you. If they ask you to evaluate an integral and they don't say anything about the Riemann sum, then usually that's just FTC, and it's going to be the integral of f prime of x from some a to b is equal to f of b minus f of a. So that's got to be like our two tools that we know for taking integrals with a table. For derivatives, we just have one rule. We did it in part A, y2 minus y1 over x2 minus x1. Now, the Riemann sum one is a lot more common, but we still need to know both. So B says using the table evaluate. Evaluate's different than approximate. Evaluate means like exact answer, which is what we have here. So that's going to be that second rule where we're going to do this integral becomes f of 10 minus f of 0. Now you could show in between steps. You could say the integral is equal to f of x and put like the bar with the 0 and the 10. But that's kind of important. So this was 1 point for getting negative 75. And then the interpretation on this, we need to remember that the integral means the change, right? So the integral of the rate is essentially the change in whatever that, when we like kind of go up that table. So integral of rate is amount. So it's the change in the amount. So in this case, f prime was the rate of flowers. So the integral becomes f, which is going to be the change in the amount of flowers. So because it's negative, we're going to say it decreased. So Mr. Corey's flowers decreased by 75 flowers between 0 and 10 weeks. So again, that time is important. If you just said that this means that his flowers decreased by 75, you're not going to get the answer. You need to have something about those 10 weeks. You could have written like the first 10 weeks, right? Because 0 to 10 is that. I like to just use the numbers between 0 and 10. Any questions on that, on part B?
I do.
Yeah.
When I wrote my explanation or interpretation, I kind of did it like in terms of the problem. So I wrote that integral describes the amount of flowers Corey has lost in his garden from time t to 0 to time 10 weeks. T equals 10 weeks. Would that be okay, or do I need to have the change?
No, that's fine. Any synonym for change, right? So you said that's the amount that Mr. Corey lost. That's the same as like decrease. That's the same as changed, right? Like all of those words. So like decreased by 75, right? Lost 75, I think is what you said you did. Changed would have to be changed by negative 75, right? Those would all be kind of synonyms for that. So that's perfect. Essentially, as long as you have the 75 number and it's clear that it went down, not up, and as long as you have the 0 and 10 weeks, you'll get the point. I think those are the two main things that they're looking for. Okay, yeah, Carlos said he thought the interpretation was asking for the integral, and essentially it is, but once you have the answer, you can use that. But that's not to say that you can't get the point without using that, right? Because this didn't actually say the answer, this said to interpret the integral. So you can do it either way. I like to do it with the 75 because we just got the answer. But I think what Carlos is asking is essentially, could we just say that the integral from 0 to 10 of f prime of x dx is the change, right, in flowers in Mr. Corey's garden between t equals 0 and t equals 10 weeks, right? That's fine too, Carlos, right? This is kind of just doing a general description. But usually what I'll do is I'll kind of go in the order that they present. So here they said to first evaluate it, and then they said interpret that. So then I'll go ahead and, since I know that this is 75, then I'll use the 75, or really negative 75. Then I'll use that in my interpretation. If they ask me to interpret it first, then I'll usually do a more general one. But yeah, if you had this, you'll still get the point. That was the correct interpretation. All right, C says the average, right? That's kind of a keyword, right? Average rate of change, average value. The average number of flowers in the garden is 1/10 integral of f of t dt. And when we look at this, this is the average value formula, right? So it's the average value of f of t, which is the number of flowers. They're not asking us to interpret this because they kind of did. But I've still seen a lot of students not understand this. So they did interpret it. It's the average number of flowers because f of t is the number of flowers. And so then they say using a right Riemann sum with 4 intervals, approximate 1/10 integral of f of t. So they want us to use a right Riemann sum. So what's important on this question is that we don't forget about this 1/10. We want to make sure that that 1/10 we preserve it. Otherwise, we're going to get 300 as our answer. So using a right Riemann sum, right, we just essentially go ahead and let's get rid of this guy. That width is 2, and we use 65. That width is 1, we use 60. That width is 3, we use 30. That width is 4, we use 5. So we kind of multiplied all those together, and then a big parentheses or a bracket to multiply by the 1/10 at the end. And we get the answer of 30. That part there, I think we should be okay with. For the most part, if you got 30 wrong, you probably just kind of messed up somewhere in your math. But if you have any questions on that, let me know. The second part, when I was kind of going through yours, a lot of people were talking about concave up, concave down, things like that. What I do want to kind of point out is that for approximations, and then like it was in an over or underestimate. So essentially we have 2 main rules and a third rule. If they put this on the AP test, they might. We've got open notes, so it might be a good idea for some of these more kind of fringe topics like this that we put together just like a little cheat sheet, and we can probably do that later as a class. But for basically right and left Riemann sums, it really depends on is f of x increasing or decreasing. And I know I've shown you guys this a lot of times. I don't worry about memorizing these. I just go ahead and draw an increasing function. And if I make a rectangle from the right, then it's our RAM here is over it. if I go from the right on this one, RAM is an under. So that means that when the function is increasing, RAM is an over approximation. If it's decreasing, RAM is an under. And LRAM would just be the opposite, right? From the left on this side, for increasing, it's an under. And the left on the increasing one is an over. So that's one rule. The other rule, and this is why I think some of us got a little bit confused, is the next rule is for tangent lines. And so for tangent lines, it depends on the concavity on F double prime. So if we have concave up, anywhere I draw a tangent line, no matter where it is, you know, here, here, wherever it is, it's always below. So concave up is always under, and concave down, anywhere I draw that, is always over for tangent lines. And then the last one is for our trapezoidal rules. And for trapezoidal rule, it's actually the same as tangent lines. It depends on the concave up, concave down. So for trapezoidal rule, think that if I had like a point here and a point here, and I make a trapezoid there, it's over it. Whereas for concave down, right, if I had a point here and a point here, or wherever it is, it's below it. So what's happening is trapezoid and tangents, they both depend on concave up, concave down, whereas right and left depend on increasing and decreasing. So that's just kind of a little review reminder for us. So in this case, they wanted to know, is it an underestimate? We go back and we see that they told us that it's strictly decreasing. So this was always decreasing. They need to tell you that. You can't just assume. So really all we need to say here is that it's an under approximation because decreasing and right Riemann. Those are like your three words that they're looking for. Let's try to zoom out a little bit. Okay. That was all over the place. Any questions on part C? I think it was pretty straightforward. Just we may have forgotten about that decreasing part. Okay. And then part D, this is the one where I had messed up the question at the beginning. So there wasn't actually a question the first time I had posted this. So it says, for the remainder of the spring from like time 10 to 13 weeks, the function that f is now given by a derivative f prime of t equals 0.3 square root of t sine of 0.34 t. Based on this model, how many flowers are in the garden at time 13? So this is where it gets to that whole f of 13 equals f of 10 plus integral from 10 to 13 of f prime of t dt. This is kind of that really, really generic formula that we need to memorize for these like rate problems, any of the rate in, rate out stuff. Anytime we're dealing with FTC, this is like our big formula. And the reason we need to use 10 here and not 0 is that they said that f prime only worked between 10 and 13, right? From 0 to 10, we were using the table. And so then where you get 10 from is you get 10 from the table. So when we go back up to the table, the value of f of 10 was 5. So this is really 5 plus the integral from 10 to 13 of that equation. You type that into your calculator and you'll get 2.9742, and you round it off and we get 3. any questions for me on either C or D? Okay. So,
Oh, I have a question real quick.
yeah.
So I did it kind of wrong, but I still got the same answer. So my integral, I did it from 0 to 13 instead, which I know, like, I kind of messed up. But since I did, like, rounding or whatever, I still ended up getting, like, the approximate of 3.
Okay, so you did like f
I
of
think
0.
I did the integral from 0 to 13.
Yeah, you wouldn't get the points there.
Yeah.
That's
I
just
think
a matter of
I
you getting lucky, probably.
I think I might have, like, typed it in wrong, or I typed it in right and then just like wrote down the wrong integral.
Oh, so you wrote down, so you typed it into your calculator, like, but then this 10 here was a 0.
Mhm.
Here's the deal with the AP exam. They're not actually trying to be super cruel to you. So if they can tell that it was just kind of like a super silly mistake, but you actually did it right, they may actually give you a 2 out of 2 there. Essentially on this question, it was 1 point. Oops. It was 1 point for the integral. So it was 1 point for this part and 1 point for the answer. Now, if you have a totally wrong integral, like if you did f of 0 plus the integral from 0 to 13 of f prime of t dt, and then magically it was just a coincidence and you got 3, you would get a 0 out of 2. Because f of 0 is not right, this integral is not right, none of it's right. But what Elvia is saying that she did was she accidentally just, she had done like the 5 part correctly. So she had done f of 10 and she had done 5 plus, and she should have written 10 to 13, but she just wasn't paying, I guess, close enough attention. I accidentally put a 0 here. But then in her calculator, she typed in 10 and she still got the 3 flowers. So if they can kind of see that, a lot of the graders will actually give you the point, because they can see that you just kind of wrote it a tiny bit wrong. They've actually done that too. This is something that, like, you don't want to count on it, right? You never want to be making a mistake. But like I have heard that in cases, like say this up here, this right Riemann sum, and say you had done 2 times 65 plus 1 times 60 plus 3 times, say here, instead of 30, for whatever reason, you just put a 20 here. There's not even a 20 on the table. You have no idea why you did that. I've heard that this was worth 3 points. Sometimes they'll give you a 2 out of 3, but sometimes they'll even just give you a 3 out of 3 because they can tell that you knew the calculus, right? Like it was just some kind of a brain freeze. So it's not something you want to count on. Like we want to be careful. But at the same time, if we're confident that we're doing the work right, we should be getting most of the points. Okay, so there's that one. The next one is this question 5 from the homework last night. I'm going to go over this one a lot faster. And so this one was our homework from last night. A was very similar, right? A was f prime of 4. So we just do the y2 minus y1 over x2 minus x1. B was actually very similar as well. But on B, we had to apply the rule from yesterday where we split it. So this would be the integral. Oh, it's not letting me type one here. Okay. So on B, we would have to split this to the integral from 2 to 13 of 3 minus, and I like to bring the 5 out, integral from 2 to 13 of f prime of x dx. So that would be kind of splitting it. And then for 3, that becomes 3x from 2 to 13. And minus for 5, that becomes 5 f of x from 2 to 13, or you could have done FTC. But essentially what you'll get from this part is from this part, you'll end up with 33. And the shortcut is just 13 minus 2 is 11 times 3. But you'll get 33 minus, and then for f of x, we have to use the table. So in the table, f of 13 was 6, and f of 2 was 1. So this is minus. Now, this is where we do want to be careful, is when we're subtracting this, if I write it this way, I need to put a big parentheses around here. So it's minus 5 times 6, but then minus 5 times 1. So if you notice, this negative sign would distribute, and here it would make kind of a double negative. So we need to be careful about that. Otherwise, I guess you could put plus and just put the negative in with the 5. That can work as well. But just be careful about that negative sign, because if you felt like you did all of your work correctly, but you got an answer different than 8, it's probably because you messed up on that negative sign. And that's kind of the most common thing I was seeing when I was browsing through a couple of the people who turned it in last night. So just skip to D, everything else was easy? Okay. So yeah, C was just a pretty generic Riemann sum. I'll skip that one. And then D had this equation of the tangent line and then the equation of the secant line, which I know is a little bit different for us. So D says, suppose, oops, there we are. Suppose f prime of 5 equals 3. So what we want to make sure that, okay, that was something that they told us. They're telling us that f double prime is less than 0. So they're telling us it's concave down. And so remember, that's going to talk about the over under approximation stuff. So if they're telling us concave down, we want to make sure that we kind of remember, okay, then tangent lines are going to be an over approximation. And so it says use the tangent line of the graph of f at x equals 5 to show that f of 7 must be less than or equal to 4. So here's their explanation. I do it a little bit differently, but it's kind of similar. So x1 they gave us was 5. y1 we don't know yet. And m they gave us was 3, right? F prime of 5 is 3. That's our slope. So we know m is 3. So now on here, right, we do know that at 5, right, y1 is -2. This is like an x point. This is like a y point, right? So at 5, y1 is -2. So we can write our equation, which would be y minus -2 equals m times x minus 5. And that gives us y plus 2 equals 3 times x minus 5. And so then now they want to say f of 7 has to be less than or equal to 4. So what we're going to do is, this is our equation. You got 1 point there. And now what we're going to do is we're going to, into that equation, we're going to plug in 7 for x, right? Because that's what they're looking for. So I'm going to say y plus 2 equals 3 times 7 minus 5. That gives me y plus 2 equals 3 times 2 is 6, which would be y equals negative 4. So that's our approximation. If instead of y, if you want to write this as like, that means that f of 7 is approximately negative 4, then that works. So positive 4. 6 minus 2 is positive 4. I don't know where I got the negative. So we're getting f of 7 is approximately 4. Now, they wanted to show that it was less than 4. Well, the reason it has to be less than 4 is because it told us about that concave down, right? It said f double prime of x is less than 0, which means it's concave down, which means any approximation I ever do, right? The tangent line is only exact. The only time it's ever exact on the graph is at the point where they touch, which is 5, right? So in like our graph, this would be 5. So at 6, at 7, at 8, at 9, even at 4, 3, 2, what we're seeing is that this tangent line is above our actual graph, right? What I'm drawing as concave down, right? This is our actual graph. Now, it might not actually look like this. It doesn't matter because we're just doing an approximation, but our tangent line is above it. So what we would say is something like, because, f double prime of x is less than 0, or we could have said because f is concave down. Either way, f of 7 approximately 4 is an over approximation. So f of 7 must actually be less than or equal to 4 because it was an over approximation, something like that. But essentially, that basically this was a hard point to get. You had to plug in 7 and get 4, but then you also had to mention that it was an over approximation or something along those lines because of the concave down part. Okay. Now, we haven't done a lot with secant lines. That was something kind of new that they threw at us. So I would be happy if you guys got, really, I'd be happy if you guys got the 2 points here. I'd be extra happy if you got this 3rd point, and I'd be impressed if you got the 4th point. So for the secant line, what's going to happen is, and let's try to add another page in here if we can. So for the secant line, now they wanted the secant line from 5 to 8. And so what I was telling you guys yesterday with the secant line is that really there is no, we're not doing x1, y1, m1 anymore because the secant line is essentially in between, say if 5 is here, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. If 8's up here, it's this line here. So we can still do x1, y1, and m, but we can use either 5 or 8. It doesn't matter which one you use, you'll get the right answer. So if we look at our table, at 5, it's -2, at 8, it's 3. It doesn't matter, you can pick. We know about both of them. So if you wanted to do x1 as 5 and y1 as -2, that would be great. But if you happen to do x1 as 8 and y1 as 3, that's fine too. Now the slope this time, though, we're not looking for the slope at 5. That would be the tangent line, right? If we did the slope at 5, what would be graphing is the tangent line, which is that, which we don't want. That was the question before. We want the slope of the secant line, which is in between 5 and 8. So that's just a y2 minus y1 over x2 minus x1. And in the table, y at 8, right, this point was 8, 3, and this point was 5, negative 2. So we get 3 minus negative 2 over 8 minus 3, which gives us 5 over 5, which is a slope of 1. So now we can graph this equation. And so, did I mess that up? Yeah, I messed that up. I thought I did. So 8 minus, I wrote 8 minus 3. It's, right, 3 minus negative 2 over 8 minus 5. So 3 minus negative 2 gives positive 5 over 3, which is a slope of 5/3. There we go. So now our equation for our secant line is y minus negative 2 equals 5/3 times x minus 5. Right? And had you done it the other way, just kind of down here, y minus 3 equals 5/3, x minus 8, this would be the same equation. So you'd get the same points had you used 8 and 3. Okay. I didn't, so I'm keeping it this way. We could have also done mx plus b form, yeah. So y plus 2 equals 5/3 times x plus 5, or minus 5. I'm not going to go into detail about mx plus b form, but you could have definitely done that. It's a little bit more work to do it that way, right? Because you would have to essentially find the slope, which is the m, and then for b, you would plug in like 5 and negative 2 and solve for b, and then you would get a b. I think in this case, the b would be, definitely it's a fraction, so I think it's, let's see, negative 25 over 3. It would be negative 31 over 3, I believe. So if you did y equals mx plus b, I think you'd be getting something like 5/3 x minus 31 over 3. Does that sound right for the people who did it? Okay. So any of those equations is fine. You're all getting the point. So that point for secant line, really the 3 that I would expect you might have gotten would be, you could get a point for that line, you could get a point for that line, you get a point even if you didn't cancel out your negatives, or if you had done with 3 and 8, you could get a point for that line. So any of those are options to get that point. Now, the next point was to then show that f of 7 had to be less than 4. So I'm going to go ahead and use this equation because that's the one I did. And when we're doing these approximations, if you want to change y to f of 7, sometimes that helps. So f of 7 plus 2 is approximately 5/3 times, right, I'm using this equation, 7 minus 5. So f of 7 plus 2 is approximately 5/3 times 2 is 10/3. Subtract 2 to both sides. When we subtract 2, it's like subtracting 6 over 3, right, if we get a like denominator. So that gives us f of 7 is approximately 4/3. Okay. Now, they wanted us to show that f of 7 had to be greater than 4/3. Well, if we just kind of think about what did they tell us, they told us this graph was concave down. Well, if I draw any secant line, which is we said it's the in-between line, then for concave down, the secant line is always an under approximation. So we would say something like, because f double prime of x is less than 0, or you could have said the same thing because f of x is concave down, the secant line is an under approximation. So f of 7 must be greater than or equal to 4/3. Simple little thing. All they're really looking for is that you connected that, hey, this was concave down, and I realize that that means it's an under approximation. And if you don't know how to do it, you're just going to kind of graph that. So what I will try to do for you guys, Carlos asked this, is I'll add in the secant line. I really don't expect them to put the secant line on there, but you never know. So I'll try to make this kind of a little bit nicer with some pictures. And I'll add in tangent lines, but also secant lines here so that we kind of have that as some notes. So I'll add that for us. Okay. Now, I know we've been doing a lot of review, but unfortunately, I do have a very easy new lesson for us, but we are going to have some homework today. So So we are having homework over spring break. It's going to be kind of at your own pace. I do that every year. So what I was saying is I'm going to essentially just give the same homework that I always give, but I'm going to modify it. Really, I said today I'm going to have a meeting with, I signed up for a meeting with some of the heads of the AP program. And they're going to kind of tell us a little bit, tell the teachers a little bit more information about how the test is going to be run. And tomorrow they're giving like that official April 3rd, more information out to everyone. So I'll try to modify it. But it's essentially just going to be like a packet that we would have had during normal class. That's just a review packet. I'll see, we might, if you guys would rather do it, we could switch it to Albert.io. What would you guys prefer? Do you think like more of just a hard copy packet of like FRQs or some Albert.io stuff? Or we just don't care? Okay. So it won't be overwhelming though. I'm gonna, I know you guys have been working really hard. We've been coming on here every day. So it's not gonna be like an overwhelming amount of work. It'll be kind of, we'll do a review packet, but it'll be a little bit easier. Yeah, I can throw a vote up on the classroom for Albert.io or maybe I'll even just post them both and let you pick, whichever one you like. So anyways, we got basically quick 5-10 minute lesson. Okay. So this is a topic that I don't think will be on the exam, but you never know. So I always save this for the very end. So it's the derivatives of inverse functions. And when I say inverse function, I don't mean trig. What I actually mean is I mean an actual inverse function. So what happens with inverse functions, if you guys remember from math 3, is an inverse function was, say you had like f of x equals 3x plus 4, right? Which is essentially y equals 3x plus 4. It was when you switched the x and the y and then you solved. So, you had x equals 3y plus 4. You'd subtract 4, divide by 3. And this would be our new y, which is our inverse function. So that's kind of like review of what the heck is an inverse function. Okay, and the big key with inverse functions, like the key concept about inverse functions, is that when you plug them into each other, they cancel out to just x. So if you do f of the inverse function, right, you plug in this x minus 4 over 3 into x, what will happen is that essentially, right, you get 3 times x minus 4 over 3. See how those cancel? And then plus 4, right? So you get x minus 4 plus 4. Those cancel, so you just get x. And so our key concept is that essentially whenever you plug them into each other, and you can plug it in backwards too, right? You could plug the other one in. So whenever you plug them in, you get x. That's like our key concept of inverse functions. So what's going to happen here is I'm going to just define that we're going to call f negative 1 of x equal to g of x for right now, just so it makes it a little bit easier. So if we're saying that g of x is our inverse, that means that f of g of x would be x, right? Because we're saying g of x is the inverse. So what's going to happen is if we try to take the derivative of both sides, right, on the left side, it would be chain rule. So the outside is f, so it's going to be f prime of our inside, like the box, times the derivative of the inside, the box, so times g prime of x. And then on the right side, the derivative of x is just 1. Well, what I'm trying to do right now is I'm trying to figure out what is the derivative of g, right? What's the derivative of g of this inverse? So I want to solve for g prime. So I'm going to just divide by the other stuff. And so we get g prime of x is equal to 1 over f prime of g of x. Now, I don't care what you copy down at all. You just need to copy down that line. So that line plus what I'm going to write below it, where g of x is the inverse of f of x. Okay. Some textbooks will just actually write this as like derivative of f negative 1 of x equals 1 over f prime of f negative 1 of x. The reason this gets kind of nasty though, writing it that way, is that the negative 1 is referring to our inverse, whereas the little prime is referring to a derivative. It's not really a 1. So it can get kind of confusing written that way. So that's why I like to write it with the g's. And I know that seems a little bit strange. And it is a little bit strange. But it's actually a simple formula once you get the hang of it. So what we're going to do is I'm going to do an example where we say, essentially, let f of x equal 1/2 x cubed plus 3x minus 4. And let h be the inverse of f. And they're just going to give us, sometimes they'll say like, given that f of negative 2 equals 14. You could have plugged that in, but they're just helping us out a little bit. Negative 14. Find h prime of negative 14. Let's clean that up a little bit. So remember, we've done this the whole year throughout calculus, that if we want to find h prime of something, first we find h prime of x, and then we plug in 14. So our formula here was that I'm knowing that h is the inverse. So my formula, it's kind of like product rule, quotient rule, things like that. It's just a rule. Like the derivative of sine is cosine. The derivative of tangent is secant squared. It's just something you got to memorize. Is that the derivative of an inverse is 1 over, now f prime of h of negative 14. Or not negative 14 here, because we're not plugging that in yet. H of x, right? We're just doing x right now. So that's our generic formula, right? And what you can kind of remember with the formula, if you want to, is that the G, like the inverse, always goes inside, right? Because it can't be G prime because we're solving for G prime. So we're solving for the G prime. So the one with G doesn't have a derivative and it's inside, and the F prime is outside. So, right, our H matches up with the H. So we're good. So that's kind of our generic formula. And now we're just going to plug in 14. So now for H prime at 14, that means that we're going to have 1 over F prime of H of 14. Negative 14. Negative. Okay, now this is where it gets a little bit more confusing. But it's just something that we have to kind of realize about inverses. So the way that inverses work is that we had f of negative 2 equals to negative 14. Well, this is our kind of our x and our y, right? Well, for h, it's always going to flip. So h of negative 14 is equal to negative 2 because we're flipping our x's and our y's for inverse functions. So what essentially is happening now is that means because h of negative 14 is negative 2, that means that we're going to have h prime of negative 14 equals 1 over f prime of negative 2, right, from there. Now for f prime of negative 2, right, that's something we've done for a long time, is just take the derivative of stuff. But we weren't given f prime, we were given f of x. So just off on the side, we would have to say, okay, we had f of x equals 1/2 x cubed plus 3x minus 4. So f prime of x equals 3/2 x squared plus 3. And so if we plug in negative 2, we get 3/2 times negative 2 squared plus 3. 3/2 times 4, right, would become 6 plus 3. So we get 1 over 9. I know that was a little bit weird, and that was definitely quick. I know I moved quick. I want to try to keep to our time and, say that we're done at 9:30 for you guys. But looking at that, what questions do we have? Okay. Yeah, I am recording it. What I'll do is I'll put a timestamp to this part of the video. So that if you want to just jump straight to this part of the video, you can. This is also our homework. So I'll do number 1 really quickly. If you guys want to leave because you had something planned at 9:30, great. If not, I'll do number 1 and then I'll stop. So 1 says let f of x equal to x cubed minus 5x squared minus 8, and let g be the inverse. So this one, they're kind of walking us through some kind of easier process of it, which is to first just plug in f of 1 and f prime of 1. So on A, f of 1, I don't think you guys really need me to show any work there. We're just plugging it in. So f of 1 cubed is 1 minus 5 times 1 squared. So 1 minus 5 minus 8. And when you do that, you get negative 12. Okay, and then for f prime of 1, before I can do f prime of 1, we need to find f prime of x, which is 3x squared minus 10. So f prime of 1 becomes 3 times 1 squared is 3. 3 minus 10 is negative 7. Okay. Then for B asks find g of negative 12. Well, the long way of doing this would be to solve for g. To like, basically the long way would be to say, okay, y equals x cubed minus 5x squared minus 8. Switch these two. And so we have x equals y cubed minus 5y squared minus 8, and solve for y, which looks very difficult because I have a y cubed and a y squared, and it just looks like it would be really, really hard to do that. But we're not going to really ever have to do that, because what we need to just remember is, hey, if I know that f of 1 is negative 12, then I know g just is backwards. So g of negative 12 gives us back 1, right? It just gives us back that answer. And so now for g prime of negative 12, the formula becomes 1 over f prime of g of negative 12. And we said that g of negative 12 was just 1. So this becomes 1 over f prime of 1, which we solved for and was negative 7. So our answer would be negative 1 over 7. And so this is kind of showing you a way that you can solve these, so that on any of these questions at all, if you kind of want to do that, like let's pick out question 4. You don't have to, but I've seen people kind of just set up a little table like that, where they just kind of set up a table and they say, okay, f of 1 equals 7. So that means below it, they put the g's, they just flip it. That means g of 7 equals 1. And here they put f prime of 1 equals. Now we're going to have to solve for that. So f prime of x in this case would be 21x squared, plus this is going to be chain rule, right? It's like a box cubed. So the derivative of box cubed would be 3 box squared times the derivative of the box. The derivative of ln is 1 over x. So now we're going to plug in 1 to that. So that's 21 times 1 squared is 21. Plus, and if you guys remember, the ln of 1 is 0. So the ln of 1 is 0, so that whole thing goes to 0. So f prime of 1 is just 21. And then for g prime of 7, it's just 1 over f prime of g of 7, which is 1 over f prime of 1, right? Because g of 7 was 1, so that's 1 over 21. And when you get good at these, you'll kind of realize the pattern is just, hey, it's just 1 over that guy. So if you kind of make that as a table, not really any AP teachers or books will show you this, but it's kind of just like a chart. It's kind of like the X method, where it's like something to just set up your stuff, where you're just going to do f of like the x1, right? And you're going to get some y1. And here it's g of that y1 equals something else. And f prime of that x1 is going to give us our answer for that. And then g prime of that y1 is going to be 1 over whatever we had here. And so that's kind of just a little bit of a like organizing your work method of doing it. You guys who are staying here, do you feel good with that? Do you want to do one more example, or we feel like we're okay? Okay, then I'm gonna go ahead and log out. Thank you guys for staying. Your homework is gonna be to finish this worksheet. Let's see. Okay. So I did numbers 1 and 4 for you guys right here. Those are kind of done. 2, 3, and 5 is similar to this. And then 6, 7, 8, 9, 10 is saying find the equation of the tangent line to the inverse. So just giving you guys a quick hint, right? Whenever we see tangent line, we know we're gonna have to do x1, y1, and m. But just be careful because it's saying find the equation of the tangent line to the inverse of f, not to f, to the inverse of f at that point. So essentially what's going to happen is that we want to do this with that inverse function. I'll post an example like for 6 if you get stuck, but it's just we're going to be using for that slope formula, right? For m, we're not going to be using f prime. We're going to have to be using that g prime of x equals 1 over f prime of g of x. So I'll post, like I'll probably do number 6 and just kind of attach it to the answer key on there. So those are that. And then lastly on this, there is a free response as well. I am going to post the answer for this free response so you guys have it. But that'll be our homework. It's a little bit of a longer homework. It'll probably take you around like an hour or so. So just make sure you budget that time accordingly. All right. Thanks guys. And I'll talk to you guys soon.